Hey everybody, welcome to how to use the half angle formulas. And we're going to mainly focus on the half angle formulas for cosine and sine, even though we do have the half angle formulas for tangent down here as well. But we're going to keep running off the idea that everything is a relationship of sine and cosine, right? Tangent is sine over cosine. Secant, 1 over cosine. Cosecant, 1 over sine. Cotangent, cosine over sine. So the main idea of this videos and the other videos is everything can already be broken down into sine and cosine. So therefore, if we just really focus our energy in learning sine and cosine, we kind of get the other ones off the relationships. So our learning goal today, so by the end of the video, hopefully we'll be able to use the half angle formulas to evaluate trig functions. And again, this is going to be mostly done by focusing on the half angle formula for sine and the half angle formula for cosine. But just because they're so popular, here's also the half angle formula for tangent. If for some reason you find yourself in a standalone tangent situation. So the half angle formulas, why are these valuable and what do we need them for, right? If we think again back to our unit circle, well, we only get nice values for 30, 45, 60, 90, 120, right? 135, all the way around the circle. Well, how does that help us if I want to find, like, which we'll see in a later example, what if I wanted to find cosine of 15? Well, that's not a nice value on my unit circle. So I could throw it in my calculator, but that's going to give me a terrible repeating decimal. That's not an exact answer. So half angle formulas, just like the addition and subtraction formula, we can build off of the things we already know, which are those values in the unit circle. We can combine those in such a way, we can either add them or subtract them together, which will put us into the addition and subtraction formulas, or now we could cut it in half. So if any angle is like half of a known angle, for instance 15, because we know stuff about 30, or what else do we know? We already know 45, 90, but anything else like 75, right? We could do something with 75. Why? Because it's half of 150, and 150 is a nice known unit circle angle. So basically, if you want to know something and you figure out, hey, this is half of something I do know, that's where these formulas really come in handy. So again, applying what we know already to this kind of new stuff. And the way that, so you'll see these plus minuses here. This is something else I have to mention. So you're like, well, how do I know if I use the plus version, or how do I know if I use the minus version? You think about where your angle terminates, right? Is your angle going to terminate in quadrant 1, 2, 3, or 4? I know I'm writing black on black. Well, if my angle terminates in quadrant 1, then I need to use positive cosine and positive sine. Why? Because cosine and sine are positive, right? Cosine here is positive, sine is also positive. If my angle terminates in quadrant 2, like 160, well, sine here is still positive, but cosine is negative. So if the angle that you wanted terminated in quadrant 2, then you would use the negative half angle formula for cosine, but you would use the positive one for sine. And so we keep going around. Here sine is negative, cosine is negative also. Sine here is negative, cosine here, though, is positive. Remember, sine acts like the y-axis. Y-axis is positive up here. Y-axis is negative down here. Cosine acts like the x-axis. X-axis is positive over here. X-axis is negative over here. Okay? So you figure out if you use the plus or minus version, again, depending on what quadrant your angle terminates, and then think, okay, well, should sine be positive or negative here? Or should cosine be positive or negative here? And that's how you tell. So we'll use some examples of this. How about white? So if cosine of A equals 3/5 and in quadrant 4, okay. Quadrant 1, 2, 3, 4. So whatever quadrant your angle terminates in, I know cosine of A is 3/5. What's cosine? Cosine is adjacent over hypotenuse. Now I need to fill in this missing leg. 3 squared plus something squared equals 5 squared. Pythagorean theorem will tell us this is 4. This is a 3, 4, 5 triangle. We need to find sine of a over 2, cosine of a over 2, and tangent of a over 2. So, sine of a over 2. Which formula should we use? Well, we're in quadrant 4. Sine is positive or sine is negative in quadrant 4? Sine is negative. So we use the negative version of 1 minus cosine of a. So if we look, okay, what is cosine of a? Well, cosine of a is given, it's 3/5. All this is over 2. This is straight out of the formula. And half angle formulas are going to get you really, really good at fraction division and subtraction and addition. Just more fraction arithmetic here. Trig is like just an exercise in how good are you at fractions. So 1 minus 3/5, I'm going to change this into 5 over 5. 5 over 5 minus 3 over 5, that would give me 2 over 5 over 2. So 2/5 divided by 2, that's the same as multiplying it by a half. 2/5 multiplied by a half, this would give me 2/10. Okay, reduce negative 1 over root 5. Divide by 2, I get 1, square root of 1 is 1. Divide by 2, I get 5, and then square root of 5 stays square root of 5. So sine of a over 2 is done. Next, cosine of a over 2. Okay, same thing. Which formula do I use? Do I use the positive or do I use the negative? Well, I'm in quadrant 4. Cosine is positive or cosine is negative in quadrant 4? Positive. So I use the positive version, which is 1 plus cosine a over 2. So now I need to simplify 1. Again, I'm going to turn into 5 over 5. 5 over 5 plus 3 over 5, it's going to give me 8 over 5. All this divided by 2. 8 over 5 divided by 2 is going to be 8 over 5 times 1/2, and we'll see this is going to be 8 over 10. Reduce 4 over 5. Square root of 4 is 2. Square root of 5 is square root of 5. So notice how this became this. Square root the numerator, square root the denominator. So we got sine of a over 2, cosine of a over 2. The last thing we're going to hit is tangent of a over 2. So I could go through any one of the 3 formulas that I have, or I can kind of be smart about this and be like, hey, tangent is just sine over cosine. What's my sine? Negative 1 over root 5. What's my cosine? 2 over root 5. Dividing by a fraction is the same as multiplying by its reciprocal. So let's flip this guy around. Cancel, cancel. And I end up with negative 1/2. So we have found sine of a over 2, cosine of a over 2, and tangent of a over 2 by using the sine and cosine half angle formulas. And then we use the ratio identity to get tangent, because we always want to work smarter, not harder. So next, this is kind of a little more standard. So how could I evaluate sine of 15 and cosine of 15? Well, I could go to my handy dandy calculator and be like, hey, what's sine of 15? And I would get a terrible, terrible eye-hurting decimal. Same thing with cosine of 15. And I don't want that anyway. I want exact values. So 15 is half of a known value, right? Hey, first off, I need to figure out how to get a over 2. Multiply by 2, multiply by 2. I would get a on the left. A is equal to 30. Basically, if you're trying to take sine or cosine or even tangent of an unknown angle, right, it's not a nice unit circle angle, but you do notice, oh, this is half. of a very nice unit circle angle, which this is, right? 15 is half of a very nice unit circle angle. The nice unit circle angle I'm talking about is 30. We know a lot about 30 for everybody. So sine of 30 over 2 equals, so now 30 is my A. So everywhere I see an A in my formula, I'm going to use 30. I am doing 15 degrees, which is in quadrant 1, which means sine is positive, so I'm going to use the positive version. 1 minus cosine of A. What is cosine of 30? Root 3 over 2 over 2. Now let's get busy with some arithmetic here. 1 is 2 over 2. So I'll have 2 minus root 3 over 2 as my numerator. My denominator is going to be 2 here. So again, 1 is equal to 2 over 2. I'm just adding fractions. 2 minus root 3 is 2 minus root 3, and then everybody's over 2. You can't combine radicals and non-radicals in addition and subtraction. It's just not going to work. Dividing by 2 here is the same as multiplying by 1/2. So what I'm really doing is I'm multiplying this guy by 1/2. So which means my numerator will stay the same. 2 minus root 3, and my denominator will become a 4. Okay, so that's what happened here. And then for all intents and purposes, 2 minus root 3, square root of 4 is 2. So this is as simple as I'm going to get here. Radicals, you can take the radical of the numerator and the radical of the denominator. That's fair and legal. So square root of 4 was 2. This is how the 2 popped out here. And notice the square root is still over everybody in the numerator. You can have square roots under square roots. And in fact, for half angle formulas, you can find that this happens more than maybe you would even like it to. So now let's hit it with the cosine. So to find cosine of 30, I'm going to use cosine of 15. I'm going to use cosine of 30 over 2, right? 30 divided by 2 equals 15. And I like this for half angle formulas because I know everything there is to know about 30 because of unit circle. So also 15 is in quadrant 1 and cosine is positive in quadrant 1. Therefore, I'm going to use the positive version of this formula. And that's going to be a 1 plus cosine of A. A is 30. Cosine of 30 is, again, root 3 over 2. So I'm just plugging things into the formula. 1 plus root 3 over 2, so similar game that we played here. Change this into 2 over 2. 2 over 2 plus root 3 over 2 is going to be 2 plus root 3 over 2. All this is over 2. You can see that this looks eerily familiar, so I'm just going to cut to the chase. 2 plus root 3 over 4. 2 plus root 3 square rooted over 2. Right? Notice the very, very slight difference here. And then if I wanted to, I could also find tangent of 15. At this point, I would just put numerator, denominator, hit it with the dividing by a fraction, the same as multiplying by its reciprocal, and I could get tangent, I could get secant, I could get cosecant, I could get cotangent, I could get everybody I want because I know sine and cosine. And that's exactly what we're going to do in this last example. So this is kind of like example 1, except for I'm finding our other 3 trig functions. Sine of A is negative 3/5, and we're in quadrant 3. Quadrant 3, throw my triangle down there. There's my A. Negative 3/5, sine, opposite over hypotenuse. Negative 3 over 5, opposite over hypotenuse. Once again, we've seen this before. This side is 4, 3, 4, 5 triangle. Why did I throw a negative 4 in there? Because look where I am in the quadrant, right? This is the x-axis. I've gone left, which means this is left 4, down 3. That's a negative, that's a negative, okay? Remember where you are in the space of like the XYZ plane. We need to find secant. And I'm going to use the simple fact that secant is 1 over cosine. And I don't have a secant formula, but I do have a cosine formula. So I'm going to find cosine of a over 2. And whatever I find, I'm going to hit it with the reciprocal, and that'll be my answer. So cosine of a over 2 is equal to, first off, where am I? A is in quadrant 3. Cosine is negative in quadrant 3. So I'm going to use the negative version of my formula. 1 plus cosine of A. Cosine of A, I know sine of A, but not cosine of A. Cosine of A is adjacent over hypotenuse. Adjacent over hypotenuse over 2. Okay, let's keep on with the fraction arithmetic. 1 is 5 over 5. So 5 plus negative 4. 1 over 5 will become my numerator. 2 will become my denominator. This guy is going to simplify. Dividing by 2 again, as you guys have come to a pattern, if you're dividing by 2, you double your numerator. Square root of 1 is 1. Square root of 10. Basically, I'm taking the square root of the numerator and the square root of the denominator. Square root of 1 is 1. Square root of 10 is square root of 10. So I got my cosine. Oop, I was already starting to circle that like I was done. So I know my cosine, which implies my secant. Cosine and secant are reciprocal, so if cosine is negative 1 over root 10, then secant, flip it, is negative root 10. All right, got the secant down. Oof. Let's tackle cosecant next, and we're going to play a very, very similar game here. Cosecant is 1 over sine. And I have a formula for sine, so I'm going to apply the formula, the half angle formula for sine, and then whatever I get, I'm going to take the reciprocal of it, and that's going to tell me what the cosecant is. You'll see this a lot in trig. Reciprocal identities, they're powerful. So sine of a over 2, plus minus, I'm in quadrant 3, sine is negative, so I use the negative version of the formula. 1 minus cosine of A is here, cosine, adjacent, hypotenuse. We'll see, we'll have a double negative here. Let's clean this up. 1 is 5 over 5. 5 minus negative 4. That'll be positive 9 over 5. That's a 9, not an A. All this over 2. Again, as we've seen, anytime you're dividing by 2, you just double your denominator. Negative square root 9 over 10. Square root of 9 is 3. So that's negative 3 in the numerator. Square root of 10 in the denominator is square root of 10. Nothing really illuminating there. So then cosecant then of a over 2. So if sine of a over 2 is negative 3 over root 10, then cosecant of a over 2 is negative root 10 over 3. Why? Because they're reciprocals of each other. So always, always, always keep your identities in mind. So that takes care of cosecant. The last guy we're going to do is cotangent. Now, cotangent, a over 2. You're like, well, that's 1 over tangent. We don't know anything about tangent. You're right. But cotangent is also a ratio identity. Cotangent is also cosine over sine. Get really, really good at these identities. They're going to be your friend, and they're going to make life a lot easier for you. What is cosine of a over 2? Boom. I got it. What is sine of a over 2? Here. Square root of 10. Okay? Negative 1 over root 10 times, flip this over. This one is also negative, 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 so we'll get a positive. Root 10s will cancel, negative 1/3. So as you notice, we kind of always get cotangent and tangent a lot easier once we find sine and cosine. So what we've effectively kind of done, except for like explicitly finding tangent in this case, I found cosine of a over 2. I found secant of a over 2. I found sine of a over 2. We found cosecant of a over 2. We found cotangent of a over 2. And then if I just flip that over, negative 3 would be the tangent of a over 2. So as you can see here, even though this video is about half angle identities, it's also kind of sneakily about, hey, remember your identities, all your reciprocal identities, all of your ratio identities. Why? Because it'll make things a lot easier for you if you remember how certain trig functions relate to certain other trig functions. Okay, so if you need to review that, get yourself a little cheat sheet, have that next to you while you're working anything out. So as always, any questions? So now it's your guys' turn. Go practice, practice, practice. Get really good at half angle identities. Again, practice, make mistakes, practice, make mistakes. Do harder problems and then practice and make mistakes on the harder problems. And then eventually you'll be so good at half angle identities that you'll be able to just rattle off these formulas off the top of your head because you'll actually know them for yourself. Okay? If you have questions at all, please don't hesitate to ask. I'll see you guys next time.